Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to the Developer Experience Office Hours. Today, we're going to be talking about simplifying and standardizing developer environments. And I have a wonderful cast of characters here. Stefan Lemire, please introduce yourself. Let us know what you do here at Red Hat. And then, we'll pass it
Yeah,
over to Elson.
thanks. So, hi everybody. Hi Chris. Thanks for hosting us today. So, I'm Stéphane Lemeur. I'm French, as you can hear, and I'm working as a product manager in the Developer Tools BU, where we are building a lot of different solutions for helping the developers to build their cloud native applications. And we have another speaker today, Elson. So, Elson, please, could you introduce yourself?
Hello, everyone. I'm Elson Yun. I'm the architect for the dev file services. So my team is mostly responsible for basically what we talk about today, the development of the dev files and all the library support and all the other things around dev files.
Nice. And we've done a few shows on dev files so far, but this show is interesting because we're actually going to try and demonstrate how to make these portable. I feel like,
Yeah, exactly.
So yeah, I'm curious to how you can make my life easier, because Lord knows I have multiple developer environments around the house, for that matter, let alone at work.
Yeah, exactly, and that's exactly what it is about. It's you know that it is a challenge to manage the different developer environments that you have. There's a lot of different pain points, and we are hearing most of the time the same things from all the developers. Oh, I need to configure my developer environment. I need to pull all the dependencies. Shit, I have to move to one microservice to another one, and there's a bunch of dependencies that I need to reconfigure. So that's what we are going to speak about today. And Elson, if you want to share your screen.
Sure.
We have a few set of slides to introduce what dev files are.
Makes sense.
And then we have some demos. Yeah.
Beautiful. Awesome.
So we are seeing your terminal.
We see your terminal, Elson,
yeah.
You don't see my, just one sec. Let me try that again.
The screen sharing dance is always a fun one. I need like a sound effect. Bobby, I know you're listening. It would be funny to have a screen sharing disaster sound effect.
Can you see it now?
Yes.
Yeah.
Okay, perfect. That's good.
Awesome. Thank you.
Thank you. Yeah. So as Chris mentioned, we are going to speak about simplification and standardization of developer environments. But I think more precisely, we are going to speak about developer environments that are codified and repeatable. So if we can go to the next slide, we know that we would love, as a developer, spending most of our time coding, but we also have to recognize that we are spending a lot of time in things that are not exactly coding. That could be managing the configuration overhead of working in cloud native applications. So you have smaller services and you want to switch from one services to another one. You want to troubleshoot that. So you want to see how all of those services are connecting all together. And there's a lot of configuration pitfalls in order to repeat that environment on your local environment. And there's also another challenge when you want to troubleshoot, is that you want to have an environment which is as close as possible to the environment from production, because what you observe on your local environment is not necessarily what is going to happen on prod. So there's a lot of discrepancies there. And as a result, the productivity sometimes is not as good as what we would love. And there's a little bit of delays in the way we can get the complete feedback loop from the local environment to the environment where we are going to test our application and also run it. So if we can go to the next slide, please. So our mission is really about simplifying all of this and accelerating the developer workflows, and also instill consistent standards so that it helps the developers to work with their projects and to switch from one application component to another one and make sure that they are using exactly the same tools all together. So next slide, please. It's okay. Yeah. So basically, what we are trying to do with DevFile and codified developer environment is to bring simplicity, in the sense that we want to allow a developer to be able to code, build, test, run, and debug without feeling any configuration pain, and still having the ability to use their favorite tools. Could be a CLI tool, could be an IDE, could be different plugins for different tools. All of that should be possible. We want to make sure that there is consistency and alignment between the local environment, the developer environment, the testing environment, and the production environment, and make sure that the turnarounds are getting faster and that the developers can better understand how their application and all the microservices that they are building are working all together, so they can troubleshoot them in a much easier way as well. So if we go to the next slide, please. And today we know that when we develop our code, so we have our IDE configure, and then we need to compile our code. We need to build it. We need to build also the image for our application. And then we might mount the local file system or do an rsync, so that each time we do changes into the source code, it gets rebuilt, and then we can see the changes as well. And we might need to attach a debugger at some point as well. So that's a lot of manual steps. There's a lot of configuration that is required to do that. It's taking a long time. If it's the application component that you are working on, that's easy because you have that set up basically. But if it's another application component that you are just interacting with and that you need to pull on your local environment just to be able to test and to debug it, then it's hard. But all those steps, most probably someone has already figured this out. And so usually what you do is that you share that on a wiki page, or you share that into instructions. But it's difficult to keep in sync. And it's usually when you have an intern that is joining the team that you realize that the instructions that you have on the wiki are not up to date anymore. That's kind of funny, but that's usually how it happens. So what we do with the dev file, next slide please, Elson, is that we put all those instructions into the dev file. And the dev file is basically a file, and its format will have the ability to get those information completely codified. The file is going to live with the source code of the application. So this way, when you pull the source code, you have the definition of the developer environment that is needed. So you can just go and code. So all those steps will be available and will be understood by the tools that you are using, so that make it completely seamless and easy to leverage in your favorite tools.
Nice.
That's a little bit about the dev file. And Elson, if you can go to the next slide. And inside of this file and inside of this format, we basically provide a way to describe the best practices for the end-to-end application development of your project or your application components. So we will have different pieces all together. So we will have the information for the inner loop, everything that is going to help you to build your source code, to build the image, to also debug your source code and run it as well. So you will have all of this information, and you will also have the definition of the outer loop. So how you will do the deployment of your application on a platform such as Kubernetes, for example. So it includes guidance about the runtime image and the different version that you want to leverage. You might have the build and the CI commands as well, and the different information that will help to connect the different services all together. So if we can go to the next slide, please, Elson. So for the developer teams, the architects, basically, what they will do is that they will define the standard way of working by defining and writing the dev file. This way, they can define exactly what are the tools and what are the different components that are needed in order to work on a particular stack. Could be a Quarkus stack, for example. So what is the version of Quarkus that I want to use? What are the images that I want to use to do that? And what are the tools as well? You might have starter projects, which will help the developers to get started and to have a sample component that they can use to kick off building their new application component. And you can also instill some compliance policies. So if you have certified a particular version of a tool or a runtime, or maybe it is a best practice for you to check for any vulnerabilities into the source code, then you can enforce that, because you will have in the definition of the dev file the ability to define what is exactly done when you are building the source code of the project. So for the developer teams, that's getting a little bit easier because they can consume the dev file in their tool. And with the Quarkus stack, for example, they will be ready to develop instantly because they will have all the tools that they need to start coding. And they will have a guided onboarding experience as well. So they know how they can build, how they can run their source code, but they will also be able to leverage the starter project as well. So this way it limits, sorry.
Go ahead.
Yeah, so this way it limits the discrepancies between the developers within a single team, but also between the different environments, being development, staging, CI, or prod. So next slide, please. So who can benefit from the dev files? Obviously, the stack providers and all the tools providers as well. If you have a runtime, a framework, or something like that, and you want to enable a community to quickly be all set to work with that runtime or that framework, the dev file could be a solution to provide a ready-to-code developer environment. For the developers, they can choose the tools that works best for them, and they can customize the dev files if they want, so they can extend them. But they can finally focus on coding instead of fighting with the different configuration aspect of their developer environments. So next slide, please. Because the way we do that is that the dev file into all the tools that we are building within our group, we use the dev files as a common layer that is serving all the different tools. So if you have a dev file for your project, you can use that inside of the OpenShift developer console. You can use that with Odo, which is the CLI for developers for OpenShift, and into all the IDE that we are building and the plugins for the IDE that we have as well. So if you have VS Code, you will be able to use the dev file as well.
Nice.
And with that, one thing that I haven't mentioned, but inside of a dev file, you will have components which are all containerized. So that's what is making the dev file very repeatable and easily portable as well. And that's how we leverage that across the different tools that you see here. And with that, I will hand over to Elson to speak a little bit more about another component from the dev file, which is a registry. And we will have some demos as well.
Nice.
Thank you, Stefan. So let's talk about that dev file registry. A dev file registry is a centralized place to store dev files that tools and developers can easily access to. It's an OCI-based registry with some REST API that we have sitting on top of it that allows people to access the content, for example, getting the list of available dev files and downloading the content of the stack as well. We also have a Go library to interact with it as well, in case you want to do it programmatically. So there are different types of registry, like public, vendor-specific, and in clusters that we'll talk about a little bit more on the next slide. So here's how we link the dev file registry, and tools together. A public registry, for example, the one at the bottom left, stores the dev file provided and maintained by the community. Any developers can freely use the community dev files. We have the official one in registry.devfile.io. We're currently working on getting a better web view on browsing the dev file in the registry as well.
Cool.
I
was just saying that's cool. Yeah, okay. Sorry.
Thanks. Any vendors can provide their own product registry. These are typical ones with specific product support or require login to access the resources related to the stack. For example, we're planning to have a Red Hat product registry, which contains dev files images that requires Red Hat login on it. Users can also install their own custom registry in their cluster as well to host their own set of dev files. It can be used by, for example, a company to store a list of dev files that can be used by the developers to develop their applications within their organization. And then regardless of which registry the dev files is coming from, the tools can be configured and use those and in the exact same way. So that's the beauty of that. Like, you can have your own custom ones, or you can just use the ready made from the community one. So everything will just work from the tools perspective.
Awesome.
So we have talked about what dev files are and who will use and benefit from them, and what the dev file registry is. It's time to obviously see some demos. So we have two demos today. One is on dev file with audio, and the other is dev file with dev workspace.
Cool.
So let me switch to my command prompt. Can you see that?
Yes.
Okay. So this demo shows how dev file helps developers easily using audio CLI as an example tool. It's just a tool that I pick, happens to have dev file support in there. As part of the setup, I have already done OC login to log into my cluster before. Let's say now I want to create a brand new Node.js application with dev file to run on a cluster. To do that, I need to create an audio component. An audio component is something that maps to a dev file that can build and run certain type of applications. To get the list of available audio component types, I can do an audio catalog list. So what it does is you take a look at what is currently basically fetched from the public community repository that I talk about briefly, and then getting the list of available dev files that can be used, readily be used. Once I noticed there's actually a Node.js stack available, so let's create one with using a Node.js example. So I'll do an audio create. Node.js is, oops, typo in there. Nuke.js create is Nuke.js is the type that I see on the list. That's the component type that I want to create. I want to give it a name, just a random name that I give it to you. I also add a dash starter flag in there, which indicates that I start from nothing and I want to just create a component with a sample application in there. So if I do that, you create that. If I just take a look at what has been created, it's a really simple Nuke.js example, because it's a starter project. You can see a service.js file in there, and there's a dev file YAML. You typically don't need to look at the dev file in details as a developers. Given that this session is actually on that file, let's take a look at that actually, what's actually inside. So in the dev file, you can find the metadata associated with it. It basically tells you what that dev file is and some extra information associated with the dev file. And you can find the container component to define what, for example, what images to be used by the tools for running the runtime, what the images can be used for doing the build, and the exposed port numbers. For example, that this particular container is exposing a certain port number for running the Nuke server, so it will be that information is there. There are also different commands defined in there as well. For example, build, run, debug, and testing. Basically, these are the instructions to tell common instructions that all the tools who understand that files will know how to build and run your particular type of application. So this is how that file looks like. In order to run that, given that we have done to create, it's very simple. We just do an auto push. So by using this simple command, it takes the instructions from my dev file, syncing the application to my cluster, and then building and deploying the application to a cluster. And you may notice that I can run this application on Kubernetes without much Kubernetes knowledge on Kubernetes at all, because all I did is just do an audio create and I do an audio push, and that's it. It typically takes a little bit faster than that. Probably doesn't look like the either the cluster is not. It's a little bit slow on this side today. Let's wait for a couple of seconds for that. Yeah, so the other thing is you notice there's a couple of starters that we have. We've got different stacks also already available in there. So we're definitely looking at expanding the list of stacks that we have.
Cool.
And basically, what you saw inside of the dev file YAML is the definition of the components plus a set of commands that you can run inside of this component. This component is a container that is getting starting on the cluster remotely. And if you are using the VS Code OpenShift connector, for example, it will understand that component, and each time you will do a build of your source code from VS Code, it will also do the build of your application directly inside of this remote environment.
Yeah. So things are actually up and running. It actually tells you what URL that I can use. You may notice on the URL that I'm using actually a sandbox environment. So that means you can easily just grab a sandbox environment yourself and then try it out yourself at home. So that's good. Everything is up and running now. If I want to make changes to the application, all I need to do is to change the code and run the audio push again. I'm not going to show that today, given that we've got some other interesting things to show. So let's say my application needs, let's talk about service binding. Let's say my application needs to use some backend services in order to function properly. Now, if I want to link a service to this application, in this cluster, I've installed a service binding operator in there. I can check out the list of available services in the cluster using an audio command. Let me do an audio catalog. So this will list all the services that's currently running on my cluster. So you may notice there's a service binding operator service that I have it running in there. Given that I have that, I've got an example service running. I can link the example service to my application using audio service create command. So let's try to do that. To create service, basically saying that I want to create a service, I need to tell it what the operator and the CRD is that I want to create with. So basically the information that I can see from the audio service listing. And that's as simple as that. I'm actually linking that to my application. So if I take a look at, let's see what's actually in the dev.yaml. So you may notice there's actually a inline Kubernetes segment has been added to the dev file for you as part of the command. So this one has got it gives you a name with the example service binding in there. And then the content of it is basically the service that I want for, this is the spec of the service that I want for creating it based on the, what's actually on the example. So, but just do that. Let's just do an audio push again. It's the exact same command that I was using for pushing the application before. And just do it, Bill. Hopefully this time will be a little bit quicker. Hoping that the sandbox environment is going okay for me. So what it does is it still takes the instructions from a dev file and then running through it. Now it's creating and create the corresponding service associated with it. So let me do an audio service list. This command basically say, okay, show me the application that has been, the services that have been linked to my application. So it's now linked to the one that we just create. If we take a look at kube resources, let's take a look at that. Just to see what's actually happening in the background. If we take a look at the kube resource, we can see from the spec field, you can see that the exact same information that has been defined in the dev file YAML. So basically, we take that instructions in the dev file and then translate it and then link the application to service. And you may notice that on the labels, it actually tells you that I'm actually linking to my applications with the that I'm having it running on audio as well. So this shows you how to give you a glimpse of how you can actually link a service to an application. So far we have seen the usage of staff from a community repo. Let's say I'm not a more advanced users and the stack in the community repo are not enough for my usage. I can create a custom registry and use my own stack to tailor for my development environment team. So let's see how I can make use of a customer registry. So in this cluster, I've got a custom dev file registry installed. Let me just do a get service. So show you the service that I have. You may notice this extra one that I have. This is a dev file registry that I have installed on the custom registry on the cluster before. If I want to see what's the URL that I can actually access to it, I can just do a get route on it. Let me copy that because I need to use that. So the idea behind the customer registry is I've got this list of another list of dev files or stack that I have available, and I want to make use of it. So to link it to audio, it's fairly simple. There's a simple registry command that I can just call add to it. I give a name of a registry that I want to label. I can see further. Oops, sorry, should put a full URL to it. Okay. So this will make audio recognize my custom registry. Now, if I do an audio catalyst components again, you may notice something different. So this is the new one that I have added to the registry. So UI-ret1 is the registry that I just got added. You can see now that by just doing that simple command, it's now recognizing what is in the custom registry that I have. I just have one single stack in there. So I can actually make use of it in the same way as what I used before. So let's try that and do our audio create. So you notice this now I'm using the new type from this list, UI Node.js. I'll give it another name for that application and just do a starter for creating a sample application again. So the application has been created. It's pretty much the same application as what we have before, but what you notice, the dev file is actually different on this one because it's actually not coming from the public community registry. It's actually making use of what we call the parent support of that. It inherits the behavior from another dev file. The user can use this parent support in that file to tailor the existing parent dev files to fit the need of the application. I can do customization on that, basically overriding the fields from the parent. So in this particular case, I'm actually calling a parent from our public registry for it. But just to show you, this is another thing that you can actually do for that file. You can actually inherit behavior from other existing dev files as well. So just that, I can just do from now on, I can just do the same audio push as before, and it will just run the application, and I can just run the, and it will just deploy as before. So you can now see that even though I'm using a custom registry, the workflow from that is exactly the same as what I will be using as a public community registry, and the same for a product registry as well. So I think, yeah, so this concludes the first part of the demo for using a dev file with the audio CLI. Let's switch gear and to look at the dev file usages in a IDE environment. So
can I ask a question real quick about the parent dev file? Like, what's the hierarchy there? If I inherit a parent, dev file from, and how do I change a setting, or say, nah, instead of this, Y release, I want a later one kind of thing. Is that possible with the inheritance process there?
Yes, you can. So,
awesome.
For example, if a normal dev file, you'll have something like this, right? You have all the fields in there. The difference between a parent dev file ones like this, after you refer to a parent, if you put the same sessions in here under the parent session, then it will just do an override for it. Now, if you just add these elements outside of the parent one, then it will do an addition. So that means I can actually define new containers on top of an existing parent dev file, and then I can just add the same, just like I'm writing a normal dev file in that case. The only difference is anything that you try to override in a dev file from the parent, you just put it on the parent session, then it will just work like that.
Cool.
Yeah, basically, the idea is that we have dev file for stacks, which can then be extended for different teams with a set of different tools. So this way I can inherit from the parent definition, use that for my own stack definition, and then I can even refine that for a dedicated project, for example. So I can really tailor the dev file to the needs that I have. But the idea is really to let some people looking at the dev file, making sure that they are looking great, they are well shaped, and they are defining the developer environment that is needed exactly the way it is needed. And then the developers, they don't have to worry about that. They don't have to touch with the YAML. They don't have to interact that much about that with this file. They just have to leverage it within their tools, as Elson demoed with Odo, but it could be with VS Code. It could be with what we are calling Dev Workspace, which Elson is now going to show off.
Yeah. And then one more point I want to point out is you may notice the dev file YAML is actually putting right into your project source. That means you can actually check that into the team repository, just like any other thing. So I can develop it with the dev file specified and customize it already. And I can check into the team repository, and Stefan can just check it out and then just run it using a different tool, and it will still behave in the same way. So that's the beauty of dev file in there.
That's awesome.
So let's go to the second demo. I've got a video on that. I'm going to show how dev file help to set up an IDE environment using Dev Workspace. Eclipse Shade has built with dev file a concept called Dev Workspace, which allows to define, configure, and start an IDE for your project. Shade adds a segment to the dev file model to define the IDE and its plugin that can be tailored according to your project's needs. This allows you to set up, define in the dev file where you are able to modify code and test it instantly. It's easy and reproducible. I have a basic application for a demo. It's a Node.js application that uses MongoDB for storing its data. Let's take a look at the dev file. This dev file has one project defined to add to the workspace. Then it has a Node.js component, which is the container where I'm going to run my application as before with the port exposed. Next, the component is MongoDB container, which is configured to be used in my application above. And the volume, since I don't want to lose my test data between dev workspace restart, I have a persistence volume component, which is mounted to MongoDB. And I have two simple commands, start and stop the application. So let's try it out. To get started with Shade, we just need the repository URL. And now I just paste the URL into there and click Create to open. So we are creating a dev workspace for our repository and wait until it's started. It may be interesting to note what's happening under the hood. Let's check out our OpenShift console. And the first interesting thing to take a look at is the dev workspace custom resources. We can see that there's one dev workspace created on the cluster. Let's take a look at the dev file YAML. Let's look at the under specs section. You can see that the dev file YAML has been embedded within the spec section. You can see the components defined in there as before, and also the volume. Now, one extra thing that Shade does is adding the IDE component, which automatically adds the Eclipse Fair editor by default for you. So let's take a look at the pods. There are 4 containers created for you. Just for information, 2 of them, one is the Node.js application defined in the dev file. The other is the MongoDB defined in the dev file, and the rest of the other 2 are the Theor editor and some utility container. So let's switch back and see whether our workspace is ready or not. So it's initializing the workspace now. So we can see that the Eclipse Shade has been has set up a Theor editor with the application loaded into the workspace already. The dev file is the one that we have before. So next step is to run our application. So to run my application, I just run my run task. The run and stop are the commands that I defined in the dev file. It's now showing up in here. I do a run command and selecting running the Node.js application. So now Shade will actually, based on my dev file information, and then run the application. So let's see. I've got the application up and running. Let's try it out. I'll add a entry of my employee in there to save everything goes well. And let's say if I want to remove this application, this user employee, when I select this, it's got an error in there. Now let's see. Go back to there's a bug on my application, so let's go back to my application to fix it. So what happens is in my application, it's supposed to be doing a request parameter, but I've got a typo in there for which I missed the underscore on the parameter. So let's fix that. And let me stop the application. And then let me start it again. After save it. So let me open up my browser. Still up. Setting up. Now application is up and running. If I try my deletion operation again, and the operation runs right. So now that I've fixed the application, I can just commit and push my changes to my Git repository as usual. So that's it for the demo. Okay, so that shows demo of that. Let me switch back to my presentation.
So I think for the demo, the thing that is pretty cool is that you have a dev file. You can use Che and dev workspace to get a complete developer environment that is running on Kubernetes to build code your application for Kubernetes as well. So you're directly coding from Kubernetes, and you have been leveraging all the different components that are defined into the dev file as well. So that's pretty cool. Actually, you can spin up a developer environment just in a matter of few clicks, and you can get going and start coding on the application. So imagine that you are working on multiple microservices and you want to switch from editing one of the microservices to editing another one. That's very handy because you just have to open it into a different browser tab, and you have an environment that is ready for you. So that's pretty cool.
Yeah,
pretty useful.
Yeah, and adding on to that, we also believe in developers have different favors of the choice of their tools as well. So that's why we try to develop this dev file format so that you can actually use the tools that you want for it. So other than audio and dev workspace, with dev file support, we have also added like a dev preview on the dev file support in the OpenShift developer console. The support allows you to basically import a Git repository that contains a dev file, and then the dev tool will run the application for you based on the information in the dev file. To use that, you can create a project to contain the application as usual. Just give a name for it. Then you can use the import from dev file tile and add an input on the repository information, or use the sample URL that we provide in as part of the UI. And once you do that, that's it. That's fairly simple. And Dev Console will just take that dev file, trying to build the application for you, and you can just launch the URL just like any other applications in the Dev Console. So the flow is pretty much the same as all the other scenarios in the Dev Console. And then other than that, you can also find some samples from the developer catalog as well in Dev Console. We have also added a dev file category for filtering to help you to easily find those dev file samples easily. Once you select one of the file sample, you can just create the app using the same flow as what I've shown before. So that's a quick intro on the dev console integration on it. So in these sessions, we have talked about how that file works and how it can help you to develop your application, how you can move it across different variety of environment, for example, a CLI to an IDE to a dev console. So we also demoed how dev files can be run in a standardized way. I hope we have provided enough information that can help you to simplify and standardize the development environment using that file. For more information, you can check out our main website and our dev file registry as well. Dev file API Git repo, that's our main repo, is there. We're currently working with another major cloud vendor for trying to propose the dev file specification together with Dev Workspace as a CNCF project as well. So I think that's it. That's all we want to show today. Let us know if there's any questions on that file.
And
go ahead.
Sorry.
Stefan.
Yeah, the push on CNCF is something that we really believe is interesting, because we see that there's multiple tools that are having some kind of a similar approach, defining developer environment in a codified way. Mm-hmm. You have things from dev containers, you have gitpod.yamls, you have other environments.yaml from Binder, for example, and things like that. So there's a lot of Kubernetes tools in the space that are looking at this problem. But we believe that there is a need to work all together on a vendor neutral aspect and a vendor neutral specification format, which can then be used by others. So it's going to be interesting, and it's going to be also probably valuable to the community overall.
Yeah, no, as a CNCF ambassador, I feel like this is something that is desperately needed in the community, right? Like a standard way to kind of keep people out of mangling YAML to get their dev environments up and running, right? Like we need that to be something that is like untouched, almost holy to an extent, right? Like these dev environments need to be repeatable because they represent what's going to happen in prod. So making that a reality is something that I think the IT industry has been struggling with for a long time, but we finally have a real good chance with Kubernetes to make it a real thing that we can do. And you're demonstrating that already. And it's kind of nice to see, because I remember back in the day passing around multi-gigabit Vagrant images,
Yeah.
right?
Yeah,
like
yeah.
I would much rather pass around a file or, a folder directory, structure of files if need be, to get up and running, as opposed to, oh yeah, by the way, you have to do all your development in a Vagrant box. And so, it's a good thing we're addressing it as, an industry and community.
I think at some point I saw some developer who were doing a zip of their Eclipse IDE, Eclipse configuration with all the plugins and so on, and sharing that together. So,
wow, I mean, yeah, that could work maybe, but it's only like half the problem, right? Like that's local dev environment. It's not a representation of, prod necessarily, right? Like
and you don't get that version as well.
Right.
So if you need to go back in time and fix an issue on the maintenance version, and you need to get an environment set up to do that, how do you do this today?
Right.
That's also a pain point. So if we have this definition of the developer environment that is getting version along with the source code, it can go a long way.
Awesome. All right. Well, folk, there are no questions in chat here. People are watching. I'm just assuming they are informed and don't have any questions, but I'll give them a few minutes to drop them in if they want. What's kind of, what's next maybe on the horizon for dev files, right? Like you just went to 2.0, I saw recently. What is the next fun
Yeah.
thing to come along kind of deal.
So we are currently working on a viewer for the dev file registry. So this will allow to browse and see all the stacks that are available on the community registry. So if anybody is interested to provide their stacks for a particular framework, they could contribute that directly to the community registry. We are also working on adding outer loop support for the dev file. So this will be part of the specification. And along with the adoption of the tool with the dev file, we are also integrating some changes and moving the specification forward so that we can adjust. We are also looking at building a tool that will take any Git repository and will analyze it to detect what is the most appropriate or the best appropriate dev file to work on that project. So that will be a good way to kick off and to
lay the foundation of like what you need. Yeah, that's cool.
Yeah, and the main idea is that is especially useful in the case where you've got an existing application that I now want to take advantage of the dev file. I want to run it in a containerized environment. So if we can actually do the detection, tells you what is the best matching stack that you can use, and you can just throw your dev file, and then it will be part of your application.
That's awesome. I mean, it's cool. That's cool stuff, right? Like, point it at GitHub repo, tell me what I need, and then go from there kind of thing. That's truly powerful. So thank you for sharing that. Appreciate it. So no questions in chat. And if y'all don't have anything else, I don't have anything else either. We can wrap, I can give you 7 minutes of your time back if you want. And appreciate you coming on, showing this off for us.
Thanks for having us. That was a
for
pleasure.
Inviting us. Yep.
No problem at all. And hey, I look forward to hearing from you in the future too. Coming up next on the channel is OpenShift Commons briefing. My calendar's being very slow. There we go. We're going to be talking about serverless and serverless functions with Nina Singh. So please tune in for that. Please like, subscribe, and share wherever you may be watching from. And we will see you out there on the streams very soon. Thank you again to Elson and Stefan. I appreciate your time today, and I will bid you adieu for now.
Thanks, everyone.
Yes, bye.